Let's continue our studies of logical volume management. Now, there are a number of other things you can do to effect changes to your LVM configuration. Let's explore those options. So let's see where we are in our task list, and we'll label this as task number 3. So let's call this particular item Resize LVMs. When we configured our LVM, we provisioned more storage than we allocated to the logical volume, which means there's some left over in the tank in order for us to extend the volume in the event of an emergency or just the general need for additional storage. So the ability to resize LVMs is an important one. There's a command for that, as there is an app for that, named LV Resize. As mentioned, there are a series of PV, LV, and VG commands. Let's just connect back to our system to confirm the presence of these commands. And if we tab out LV using tab completion, a number of these commands relate to LVM, including LV Resize. LV Resize resizes a logical volume. Now currently, if we LV display, you'll see the current size of log_vol var, which is set to 5 gigabytes. But VG display shows that our volume group is actually 8.23 gigs. So supposing we needed an additional gigabyte of storage or terabyte or what have you, LV Resize is there to the rescue, setting the size to 6 gigabytes instead of 5 and pointing to the dev location for the volume group / the logical volume. The hierarchy is always referenced in commands, and that is from the volume group down to the logical volume level. So this will resize log_vol var, but the storage doesn't become immediately available. Let's see what happens when we execute this particular command against the logical volume. So just like that, let's check the exit status. It has resized the logical volume to 6 gigabytes. Now let's LV display again the full path to dev vol group var log_vol var. And indeed, it's now 6 gigabytes. How about when we execute df-h to reflect our mount point, which is LVM var1. It still reflects 5 gigabytes. What if we executed mount A to remount all of the items described in etcfs tab? It's still 5 gigabytes, and that's because from the perspective of the file system, it doesn't know about this additional gigabyte of storage. So the resizing of a partition usually is a two-step process, which entails reallocating the space using the logical volume tools and resizing using the file system tools. Also, as a warning, the resizing of volumes should normally take place in single user mode. So in addition to LV Resize, we need to resize the file system. We can do so using resize 2fs followed by the mount point or the dev tree location. Either or will suffice. Now the mount point is simply LVM var1. So let's Control-Shift-C to paste this into our notes and then copy the entire block. Resize 2fs allows you to resize both extending and reducing ext compatible file systems 2, 3, 4. Now we do need to specify the size, and that's going to be 6 gigabytes, and it knows that it's a directory. Doesn't take as a consequence. So let's try to access it via its dev location, and that will be dev vol group var log_vol var, and let's check our syntax. It should be 6G. So now this is resized. Sometimes it works with the mount point. In this particular case, it didn't. So with that said, we should now have the new storage available. Let's update our notes to include the fact that we reference the dev location instead of the mount point. And that's dev vol group var log vol var. Perhaps if you're using a later version of Enterprise 6, the mount point is supported, and to extend it, we reference G without a B. So this extends the file system to 6 gigabytes. Let's confirm as such. And now it's 6 gigabytes. So it was an online resize. Normally it's safe to resize a file system in the upwards direction, or positively, or extension, via extension, than it is to reduce a partition or file system due to the possibility of data corruption. Extending a file system means adding space, which should not interfere with existing space, whereas reducing, of course, runs the risk of interfering with existing storage. So again, two-step process. You extend the logical volume, and then you resize the file system using the appropriate string. And then once the resize process has taken place, immediately online, the additional storage becomes available in the mount point. So this is in place. You can also resize in the opposite direction. So although the logical volume has 6 gigabytes available now out of the 8.23, supposing we wanted to reduce it to 4 gigabytes so that we could make space for another logical volume. So currently 138 megs are being used. That means the bulk of the storage is unused. So a reduction in the opposite, or resizing in the opposite direction, which is a reduction, should cause or pose no harm or issues with respect to our data. So let's just note that LV resize, and we want to set the logical volume this time to perhaps 4 gigabytes. The full location log vol var. This will reduce the logical volume to 4 gigabytes. Let's try this out. And of course, whenever reducing, an warning message is presented indicating that you could lose data, but we expect to not lose data because we're using a small fraction of the total storage. So let's reduce log vol var, and now when we LV display dev vol group var log vol var, we see that it's been set to 4 gigabytes. However, let's df-h. The kernel still sees the mount point as 6 gigabytes because the file system is still configured to be 6 gigabytes, which means again we need to resize 2fs in order to reduce the file system. Let's go ahead and include that command as resize 2fs, and this applies again to ext2, 3, 4 file systems. So no need to use a separate set of tools as you had to with prior versions of Red Hat Enterprise Linux. So setting this to 4 gigabytes. Again, reductions are always risky in the event. And this mentions that online shrinking from this size to this size is not supported. And it knows that it's online, that it's mounted. And let's go ahead and do a df-h. Notice it hasn't made the change. So what does that mean? If we umount LVM var1, that drops it, so it's no longer accessible, which means files cannot be changed currently. Now let's try to resize it again to see if it'll take. And it tells us that it wants us to run the checker first just to make sure that it's consistent. So let's run the e2fsck checker to check it for consistency. And if this runs successfully, then we will try to resize again. Let's try the resize command again, and it still doesn't take. Let's double check this. And according to superblock, the physical size is this, either the superblock, and we'll tell it not to abort. And let's try it again, ignore error. and this is because of the discrepancy in the sizes between the logical volume and the underlying file system. So this will generate errors invariably. So one safe way of doing this is rebooting to run level 1 mode, where you have exclusive access, and then resizing it, or moving your data off to some other location and then redoing it altogether. This could go on and on forever, which is why reducing the file system usually proves to be more problematic than extending